Good day, students. I hope you're all doing well. In this video, we're going to discuss an introduction to business analytics, business intelligence, data mining, and data science. So, what is business analytics? Business analytics, or BA, is the practice and art of bringing quantitative data to bear on decision making. The term means different things to different people and organizations. Consider the role of analytics in helping newspapers survive the transition to a digital world. One tabloid newspaper with a working class readership in Britain had launched a web version of the paper and did tests on its homepage to determine which images produced more hits: cats, dogs, or monkeys. This simple application for this company was considered analytics. By contrast, the Washington Post has a highly influential audience that is of interest to big defense contractors. It is perhaps the only newspaper where you routinely see advertisements for aircraft carriers. In the digital environment, the Post can track readers by time of day, location, and user subscription information. The Post can track readers, and in this fashion, the display of the aircraft carrier advertisement in the online paper may be focused on a very small group of individuals, say the members of the House and Senate Armed Services Committees, who will be voting on the Pentagon's budget. Business analytics, or more generally, analytics, include a range of data analysis methods. Many powerful applications involve little more than counting, rule checking, and basic arithmetic. For some organizations, this is what is meant by analytics. The next level of analytics, now termed business intelligence, or BI, refers to data visualization and reporting for understanding what happened and what is happening. This is done by use of charts, tablets, and dashboards to display, examine, and explore data. BI, which earlier consisted mainly of generating static reports, has evolved into more user-friendly and effective tools and practices, such as creating interactive dashboards that allow the user not only to access real-time data, but also to directly interact with it. Effective dashboards are those that tie directly into company data and give managers a tool to quickly see what might not readily be apparent in a large, complex database. One such tool for industrial operations managers, for example, displays customer orders in a single two-dimensional display, using color and bubble size as added variables, showing customer name, type of product, size of order, and length of time to produce. Business analytics now typically includes BI as well as sophisticated data analysis methods such as statistical models, and data mining algorithms. The data mining algorithms are used for exploring data, quantifying and explaining relationships between measurements, and predicting new records. Examples are methods like the regression models are used to describe and quantify on average relationships. Example, between advertising and sales. Another is to predict new records. Example, whether a new patient will react positively to a medication and to forecast future values. Example, next week's web traffic. Examples of predictive analytics are the following. The widespread of adoption of predictive analytics coupled with the accelerating availability of data has increased organizations' capabilities throughout the economy. A few examples are first, credit scoring. One long established use of predictive modeling techniques for business prediction is credit scoring. A credit score is not some arbitrary judgment of credit worthiness. It is based mainly on a predictive model that uses prior data to predict repayment behavior. Another example is future purchases. A more recent and controversial example is Target's or the Target company. Its use of predictive modeling to classify sales prospects as pregnant or non-pregnant. And those classified as pregnant could then be sent sales promotions at an early stage of pregnancy, giving Target a head start on a significant purchase stream. Another example use of predictive analytics is for tax evasion. The U.S. Internal Revenue Service found it was 25 times more likely to find tax evasion when enforcement activity was based on predictive models, allowing agents to focus on the most likely tax cheats. What is data mining? Data mining refers to business analytics methods that go beyond counts, descriptive techniques, reporting, and methods based on business rules. While we introduce data visualizations, which is commonly the first step into more advanced analytics, we will focus in our course mostly on the more advanced data analytics tools. Data mining specifically includes statistics or statistical and machine learning methods that inform decision making, often in an automated fashion. Prediction is typically an important component, often at the individual level, rather than asking what is the relationship between advertising and sales. We are interested in what specific advertisement or recommended product should be shown to a given online shopper at this moment. Or we might be interested in clustering customers into different personas that receive different marketing treatment, then assigning each new prospect to one of these personas. The field of analytics is growing rapidly, both in terms of the breadth of applications and in terms of the number of organizations using advanced analytics. As a result, there is considerable overlap and inconsistency of definitions. The term data mining itself means different things to different people. To the general public, it may have a general, somewhat hazy meaning of digging through vast stores of data in search of something interesting. One major consulting firm, for example, has a data mining department, but its responsibilities are in the area of studying and graphing past data in search of general trends. There are also more advanced predictive models and are the responsibility of an advanced analytics department. Other terms that organizations use are predictive analytics, predictive modeling, and machine learning. Data mining stands at the confluence of the fields of statistics and machine learning, also known as artificial intelligence. A variety of techniques for exploring data and building models have been around for a long time in the world of statistics, like linear regression, logistic regression, discriminant analysis, and principal components analysis. But the core tenets of classical statistics, which is computing is difficult and data are scarce, those do not apply in data mining applications, where both data and computing power are plentiful. This gives to the definition of Daryl Prigibbon. His description of data mining is statistics at scale and speed. Another major difference between the fields of statistics and machine learning is the focus in statistics on inference. In contrast, the focus in machine learning is on predicting individual records. In comparison to statistics as well, data mining deals with large data sets in an open-ended fashion, making it impossible to put the strict limits around the question being addressed that inference would require. In our course, we will use the term machine learning to refer to algorithms that learn directly from data, especially local patterns, often in layered or iterative fashion. Next is what is big data. Data mining and big data go hand in hand. Big data is a relative term. Data today are big by reference to the past and to the methods and devices available to deal with them. The challenge big data presents is often characterized by the 4 V's. The volume, which refers to the amount of data. Velocity refers to the flow rate or the speed at which it is being generated and changed. Variety refers to the different types of data being generated. It can be of type currency, dates, numbers, text, etc. Veracity refers to the fact that data is being generated by organic, distributed processes. Example, millions of people signing up for services or free downloads and not subject to the controls or quality checks that apply to data collected for a study. Next, we have data science. The ubiquity, size, value, and importance of big data has given rise to a new profession, which is called the data scientist. Data science is a mix of skills in the areas of statistics, machine learning, mathematics, programming, business, and IT. The term itself is thus broader than the other concepts we discussed earlier, and it is a rare individual who combines deep skills in all the constituent areas. Some authors describe the skill sets of most data scientists as resembling the letter T, deep in one area, which is the vertical bar of the T, and shallower in other areas, which is the top of the T. Here are the different data mining concepts and techniques that we will cover in our course. First, we have data preparation, exploration, and reduction techniques, and then we'll also cover unsupervised and supervised techniques. We have prediction algorithms such as linear regression, k-nearest neighbors, regression trees, neural networks, ensembles. Under classification, we have k-nearest neighbors, naive Bayes, classification trees, logistic regression, neural networks, discriminant analysis, ensembles, time series forecasting are regression-based and smoothing methods. We will also cover association rules, collaborative filtering, and cluster analysis. Then we'll also have different examples of model evaluation and selection. We'll have performance in evaluations, deriving insight, and model deployment to score new data.